Welcome to Real Civil YouTube channel. In this video, I am going to show you how to analyze a truss by using etabs software. Problem statement is here, geometry is here with us, load calculation I have done, also the results by manual calculation I have. We just need to check with our software results. Okay, so just go and open the etab software. Here come to the file, new model. Here use built-in setting metric SI Indian IS 800 2007 and IS 456 2000. Now here you have to come to the custom grid spacing. Go to edit grid data. First of all we will delete here. Now if you see our geometry here, it is 1275. Distance is given. Okay, and this total span of the truss is 15.3. So simple, just add 1.275 and just go and adding up to 15.3. Same distance is there. Okay, now here for Y only one grid is sufficient. Click on OK. Now here only one story is required, so come to custom story data, click on edit stories data. Now you can delete all these, we will not require these stories. Now the distance is, if you see here, rise of truss is 1.53. Here you can see the rise of truss is 1.53. So here just 1.3. OK. Click on OK again. Now for better working, go to elevation and select this one. Click on apply, click on OK. Now here we need to draw. So first of all we have to define our section property. Okay, I will import one angle section. Here you can choose any angle section. Okay, now let's draw it from beam point of view. Here we will select 60-65, that is the angle we have selected. Now here you can draw 15.3. Okay, now select this particular and divide it into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, in 12 parts. So go to edit frames, divide frames into 12. Apply. Okay. Now we have to draw again this portion. Okay, this inclined. So this point is at the above 7th joint. Okay, so first, second, third, fourth, fifth, sixth and 7th joint. Now just select and then again join this. Now if you see the geometry, we have to divide this frame into 1, 2, 3, 4, 5, 6 into the 6 number of segments. Now select this and this is also into 6 part. So go to edit, divide frames 6. Click on apply. Okay. Now we have to draw the vertical members. Okay. So you can draw all the vertical members first. I can move this because we don't want the 3D view right now. We are comparing it with manual calculation, hence it will be convenient us to check the results, or whatever process we are doing is correct or not, because software always give results. Okay, last here we have done the same project on STAD Pro also. Okay, now here you can see we are joining this way. So click on this particular joint, select this joint. Okay, now we have to draw in this way. By method of section, we have find out the member forces. You can also find these member forces. Last one. Okay. Now, first of all, we will remove all these joints. Okay. By default, there are supports. First of all, we will delete all these. Select the node. So we'll go to assign joints restraints. Here we will select the last one, apply. Now we will select this particular. Here we will give the pin support, and at this end we will give the roller support. Okay, now the support has been assigned. Now we have to give the load conditions. We have to apply the load as per our calculation. So there are dead load, live load and wind load. So first of all, we have to create these cases. In define, go to load patterns. For dead load, I will create the case as a super dead load, SDN. Also select here super dead. Click on add new load. Second, live load is already here, so I will create wind load case. Select here wind. Click on add new load case. Okay. Now we have to assign these loads. Okay, first of all, dead load per panel point is 2.2 and at the end panel point it is 1.1. Okay, so first I will select all these internal joints. We know assumption in the truss that load is applied only onto the joints. So we have to select the joints. Right. We have selected the joints where 2.2 kilonewton load we have to apply. So go to assign joints load forces. Here select the super dead load case and global Z it is minus 2.2. Now apply. Here you can see the load has been applied. Now select the last two joints and here intensity is half. Click on apply. Now again select all these joints because we have to apply the live load. Okay, carefully select the joints. Now select here live and the live load case is load intensity is 3.837. We can write 3.84. So give here 3.84. Click on apply. Now last two joints you have to select. Here it is I think 1.92. Click on apply. Click on OK. Now we have to apply the wind load. Wind load I am applying in a different way because wind load is perpendicular to this inclined members. So we can apply through member forces, right? So for that we have to select all these. First of all, select these members. Okay, we will apply at the initial of this member, so definitely it will going to apply onto the joints. So first select these, go to assign, go to frame loads, point loads. Here select the wind load case, select the absolute distance. Okay, now here select local 2, because local 2 means for that particular member, those we have selected perpendicular to that member will the load will be applied. So the intensity of load is 7.277. So distance will be 0 and load will be 7.277. Now click on apply. Okay, here you can see at the joints in the perpendicular direction the load has been applied. Now next is we have to select these members. Okay, so we have to give the distance here, end distance. So for that just close this, or you can see the distance by right clicking and going to geometry. It is equal to 1.3002. Okay, so select all these members. On at the end we are going to apply the distance. So go to assign frame loads, point loads. Okay, add to existing load. Here we are going to give the distance 1.3002. Intensity will be full. Click on apply. Okay, I think we have to once again select these members. Okay, and keep the distance 0 and replace these existing loads. Okay, now it is okay. Now the remaining portion is we have to select this member and we have to apply the load once again. Go to assign frame loads, point load. Okay, now in this case go to add to existing load. Here in this case half intensity load will be there, 3.64. so here intensity will be 3.64 and the distance is 0, so the load will be act at the initial. Click apply. Okay, now here we have to give the distance 1.3002, right? So go to assign frame load, point load, add to existing load. This distance will be 1.3002. Intensity will be half. Click on apply. Okay, sorry, this will be 0. Sorry, just replace the existing load and select this particular apply. So this will be 3.64 at the end. Now only portion is remaining is this joint. Here also half load will be acted. So if you select this particular point and give the distance 1.3002, so the load will be act at the end. Add to existing load. Okay, now once again select this and keep the distance 0 and apply. Sorry, we have to give the distance 1.3002. Sorry, we have to select this and apply. Okay, now this load has been removed because we have selected replace existing load. So here the distance will be 0 and here will be 7.28 and we have to add this load. Sorry, 1.3002. Add to existing load. Okay, so I think the concept is clear to you that all these internal loads, nodes, joints, the intensity will be 7.28 and this point, center point full load will not be act, half load will be act from both sides. At this end joint there will be 3.64 half load intensity. Here also half load intensity will be here. Okay, so this is the concept. Now we have to analyze our truss. Okay, you can go for load combination also, but first we will go for analysis. We have to save our project. Okay, now we will check our results. If you see the axial force 60.55 kilonewton force should be there. Okay, so go to display forces. Display forces, and here you can select the super dead load case. We want to check the axial forces and click on apply. Click on OK. Okay, right, if you see here it is 57.044. Okay. Before that we can check the reaction. So go to forces, support reactions. Tabulated, apply. Okay. Support reaction is 13.22. Right. So if you see the total load intensity 2.2, you can check on the calculator. Just wait a minute. Okay, here one thing that I have not done is this is the truss. So we have to select all these members. Okay, that's why manual calculation is very important. Whenever your answers are not matching, something is missing. Okay, so as we know that at that case 57 or something answer was coming, but here we have manually calculated as 60.55. So you have to select all the member forces. Okay, now go to assign frame. Before that you have to unlock the model. Okay, go to assign, go to frame, go to releases. Now give the releases here and click on apply. Click on OK. Now there will be releases. Okay, truss is a, we know it does not bend. There will be axial compression or tension only. Now you can go for analyze, run analyze. Okay, so we'll cut this view. Now go to display. We will select axial, super dead load will be there. Click on apply, click on OK. Okay, now here you can see 60.5 kilonewton is the force, and by manually we have calculated 60.55. So axial force by etab is 60.5. Now also you can check the reactions also. So you can go for here display, go for forces, go for support reactions. Okay, here just click on apply. Okay, the support reactions you can see here 13.2 and 13.2. You can calculate it. Here you can see 2.2 is the panel per load. So if you select this or see this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 into 2.2 and half load means again you have to add 2.2. So if you see on the calculator, I think it is not getting opening. So you will definitely get this 3.13.22 reactions. Okay, similarly you can check for the live load, check for the wind load, okay, and comment below in the comment box that whatever axial force you are getting manually for live load and what axial force you are getting for this particular using etabs software. You have to comment in the comment box. Okay, so then you can go for design process also. Here steel frame design is there, so start design and check, so it will automatically do the design, right? So if any member fails, it will show that the member will be failing or not. So this video is going very long, so design related we will make another video. Okay, up to this analysis you have to do, you have to compare manually, and the next video I will show you how to design the truss in etab. We have just analyzed but we will see the design in the next video. Okay, if you have any doubt, you can comment me, you can comment on our Instagram, or you can message me on the Telegram also. Okay, thanks for watching the video. Please like, share, subscribe the video. Thank you.